The term hydrostatic, as it refers to hydraulic circuits, is any circuit using a pump in combination with a hydraulic motor. In this section, you'll learn the difference between an open circuit and a closed circuit, the purpose of the components used in these circuits, and the basis of operation of hydrostatic circuits.
In an open circuit, hydraulic fluid supplied to the pump inlet comes from the reservoir and is returned from the actuator back to the reservoir. In most open circuits, hydraulic fluid is fed to the actuator by a directional control valve and returned to the reservoir in the same way. This first circuit is a basic system with a hydraulic pump and a hydraulic motor. When the pump is in operation, flow is directed to the hydraulic motor, causing the motor to rotate. If the pump is not rotating, the hydraulic motor will not turn. In this circuit, a directional control valve is added to the circuit, and a bidirectional hydraulic motor replaces the hydraulic motor. The directional control valve will allow the hydraulic motor to reverse direction when shifted. This circuit adds an adjustable flow control valve and a pressure relief valve. The flow control valve allows for variable output speeds from the hydraulic motor. The pressure relief valve protects the system from overpressurization and will shift as the system pressure increases due to flow restriction in the flow control valve. In this circuit, a variable pump has replaced the fixed pump. The flow control valve is removed, an open center directional control valve is added, and a filter and heat exchanger are added to the return line. The directional control valve allows for forward or reverse direction of the motor and freewheeling of the hydraulic motor when the valve is centered. The filter and heat exchanger will condition the fluid before it returns to the reservoir. The variable pump will now allow for variable output speeds from the hydraulic motor. If the hydraulic motor rotation is restricted or stopped, the high pressure relief valve opens, protecting the system from overpressurization.